Viram, can we wait till 2:15? Meaning 2:15, I think looks like everybody will come at 2:15. I had said as 2:15. Is it okay, Viram? Hello, Abhiram.
Thank you. So what are we doing after this? I have to go in and finish my door. You want to finish your door? Yeah, but. I just have to. No,
Nidhi, we'll start in 5-6 minutes. Nidhi, are you able to hear me?
Yeah.
think we'll go ahead now. Is there anybody else expected to come? Let me check.
Wow. Even more in the back.
Shall we move on?
All right.
Shall we go ahead? Hey guys, can we go ahead? Are you all there? You guys, are you able to hear me? Abhiram, Nidhi, Bhuvanesh. Abhiram and Nidhi.
Hear you.
Abhiram and Nidhi, we are not able to hear you.
Oh yeah, can you hear me?
Yes. Abhiram, how about you? Abhiram? Oh, okay. Okay, Abhiram, we are not able to hear you. Okay, shall I go ahead or you want me to wait? Okay. So, any questions last week on exponential function? Any questions on exponential functions? Guys, you need to be able to answer, otherwise how can I go ahead? Hey, you're able to hear me?
Yeah.
Okay, did you have any questions last week? What is going on in your school, Bhuvanesh?
I don't know what's going to start next 9 weeks.
Oh, okay. Okay, so last week, what did we cover in this class? Did we not cover arithmetic, geometric sequences and stuff?
Yeah, I think we did the geometric and arithmetic.
Okay, so I'll continue from there. So we will cover exponential functions in detail today, but we will also do a review of what we did last week, okay? So first, let me review arithmetic geometric sequences.
Doing well.
Yeah, let's do this problem and then we'll move on, okay? Couple of problems we'll do and then we'll move on. How about this? Which of the following equations could represent the sequence 1, 4, 16, 64?
Is it number one?
Okay, you can do it in chat. I'm waiting for the others, Nitin.
Yeah.
10th one, right?
So, let me show you all to the party room.
There can be multiple answers.
Yeah, we can.
There are multiple answers, Nitin. That's right, Nidhi. What are they doing in school for you, Nidhi?
I think next week we're starting exponential function.
Oh, okay. Okay, and Nidhi, I want to confirm with you, are they covering similar to what we are doing?
They are.
Okay. Okay, because what I see honestly is all AP Pre-Calc is one and the same. There should not be any difference between any ISDs because otherwise we can't be preparing for the exam. Abhiram, there are multiple answers, Abhiram. Bhuvnesh, did you get it?
I'm doing it.
Sure. Abhiram, there's one more answer, Abhiram. We are just reviewing the part one that we covered last week. All of you got the answers. So the second one, I will review two more problems in the second part that we discussed last week after this. Abhiram, that's right. Adarsh, do you have the answer? Abhiram, if you're done, you can go ahead and do this one, Abhiram.
Yeah, so our.
Bhunesh, that seems incorrect, Bhunesh. I can do it on the board.
Thank you.
So 65th term, right? Abhiram, do you want to explain? Nidhi, we are waiting for your answer for the first one. Nitin, we are waiting for your answer. Nidhi, you got it right. Nitin and Bhunesh, you want to answer or how is that?
I'm doing it right now.
Uh-huh. Bhunesh, that's correct.
Yeah.
Let's go.
We were talking with each other a lot.
Nitin, did you get the 65th term?
Yeah,
Of a turn
Okay.
off,
It's an arithmetic sequence, right?
Yeah.
Basically adding 3. So what will be the nth term? An will be equal to, if you take the first term, plus n minus 1 times d, right? Common difference is 3. 65 is n. You're going to substitute that. A1 is whatever is given, minus 46. When you substitute that, others, you can do the next one. If you are not knowing it, then I can help, I feel. So here, minus 46 plus 64 times 3, right? Some reason, it's a little slow. 1 second, guys. Minus 46 plus 64 times 3 is 12, 192. So now 192 plus 46 will end up with 1. 46. Nitin, did you get the answer?
Yeah.
So can you all do the second problem? Passing through two given points. Passing through two given points, right? First you find out R and then substitute the value of R in the general equation. Guys, you're able to do, or do you want me to do it on the board?
If somehow bring stuff into the party.
I think I can. Yeah.
Oh yeah, yes, ma, I can, but I need to know, right? Yes, I can do it. So, okay. Here, when you see, when you put it in the form of a table, right? So you have been given the 8th term and the 10th term. 8th term is 12, 10th term is 10. With this in place, right? Now, how many common ratios are between? How many common ratios are there between 8th and 10th term? To answer my question, there are two common ratios are there, right? So basically R times R. So can I say R squared? You see, that is a difference, R square, right? So when you think about 8th term, 10th term, right? So 8th term times R will give you the 10th term, right? So what is R value in here? Would you be able to find out the R value? So basically, how can I do it? Let me go. Here, 10th term is what? 6. So 6 equal to 8 times R square. Can I write it like that? So in this scenario, I'll say R square equal to 6 divided by 8. So that will be equal to 2 by 3. Now, my general format of the exponential function is f of x will be equal to a b power x, right? So now b power of a b power of x. Now, the thing about this is, you know what is b, okay, here we have found out r square, right? Can you use this r square and write out your exponential function? Would you be able to do, or do you want me to do that on the board?
I think I can do that.
Okay, try, otherwise I'll do it on the board. A is basically the first term, right? After that, that b is r basically. So if you can, you do it, otherwise I'll do it on the board. So here I can finish this and give you another one of the same type is what I feel. Let me go ahead. So f of x will be equal to, the first term is what? Oh, we don't have the first term. Okay. So we need to use the two values, x comma y values are there, right? So let's find out that. Oh, this is a little difficult, guys. Let me go ahead and do this one for you. But last week we did this, we ended with this. Okay, let me do it for you. So basically we don't have the values y equal to a times r power of x is there, right? So here my problem is I don't have the values, okay? So x comma y is there, you can find out a. So x comma y is anything 8 or 12. So a, r you have, power of 8 is 12. Now from here, you can find out the value of a. So basically, how will this work? What is the first term of the sequence we need to find out, right? So let's find that. So this would be A is equal to 12 times 3 by 2 power 8. Right?
I think,
So now
I think.
I will write the
The kids
equation
that
as,
didn't show up.
one second, yes, I'll write the final equation as this.
Well, thank you for the help. No problem.
This was
Is there anything
12,
you should
okay.
do to update Corey
So I'll write the final equation as A x power of, so
on?
I'm finding it hard to write, guys. Give me a minute. I think I'll have to switch the internet connection. I think, give me a minute.
The final challenge.
Yeah.
So I don't think.
Okay.
In this case, this is,
Doesn't actually matter what they do today.
this is the kth term, right? So remember our formula for the kth term, this given the nth term first term, but we are given the kth term, meaning y here is the kth term. So I need to add this. I will finish this problem, disconnect my internet and come back, I feel. So kth term, you need to subtract it in here, right? So here, when you think about it, we found out the A value. Guys, can I disconnect and come back in a minute and work out the same problem so I'll be able to write properly? Is that okay with you? Just please hold on. Can I do that?
Yes.
Okay, just give me 1 minute. I'm going to switch my internet. I'm not able to write properly, so hold on.
Okay, but I'll take a look at it. Well, we can just leave it right there.
Give me 1 minute. I'm going to switch my internet, so I might be disconnected for a. Hello, Nidhi, Abhiram. Guys, are you able to hear me?
Yes.
Guys, okay, that's good. Okay, let's move on. Let me go back and do this problem. It's gone, right? It's okay. I'll do it again. So yeah. So this is one x comma y. This is one x comma y, right? So I've been given the 8th term and the 10th term, right? So how much of difference? Remember our kth term formula. So g of k will be equal to the kth term, right? G of n will be equal to g of kth term and then r power of n minus k. This was our general format, right? Now we have been given 8th term and the 10th term. So let me put down the value of the 10th term. G10 will be equal to 8th term is as well given. So r power of n minus k, which is 10 minus 8. So G10 equal to G8 times R square. Now R square equal to G10 by G8. What is G10 and G8? 6 by 12. Okay, that was a mistake there. So 6 by 12 is 1/2, right? 6 by 12 is R square equal to G10, correct? 6 by 12. I took it as 6 by 8, I think, last time. So 6 by 12, 1 by 2. So R will be equal to square root of 1 by 2. Any questions still here? Any questions still here? Guys, did you have any
No.
questions still here? Okay. So now I think we substituted it wrongly the first time. I don't remember, but I was not able to write properly. I didn't follow it properly. So R will be equal to square root of 1 by 2. Now I'm going to go back and substitute it in here. What I'm going to do? Gn. So now that will be my y value. So basically, we have the R value. So in terms of X and Y, I need to write down the equation, right? We can use either of these. Okay, we can use either of these as my X and Y. Okay, so N is actually X, Gn is actually Y. You got it, right? So that being the case, I can use these two values first. If I use these two values, then I will get Gn is 12 will be equal to GK.
Hello.
Okay, that is your Y value, right? So
So I've got a quick, format.
R power N minus K. N minus K is, see, N minus K is,
For the party.
what is my N value here? N is X value, N minus K. So N minus K is going to remain the same. So N is, I have taken it as, this is N comma Gn or comma Gn. So N minus 8. So I will take it as X minus 8. So here this will be equal to Y. So my final answer would be Y will be equal to 12 times Y will be equal to, eighth term is what? In our equation, I can substitute GK, right? Yeah, eighth term is 12 square root of 1 by 2 power X minus 8. Any questions, guys?
So, got a quick-
Any questions? Suppose, okay, suppose you can use the other term, right? If you use the other term, your value will be, Y will be equal to 10. Because if I use this term, right? Square root of 1 by 2 power X minus 6. Any questions, guys? Any questions? Any questions here?
No.
Okay, I'll do one more if you want to on this one. Let's see. So much better. Okay, hold on. Let me do one more, but we did this last week. I don't know whether you guys remember or not. How about this one? Okay. I have to write down the equation that passes through these 2 points. It's an exponential function. So what do I do? So again, I go with the general format, Gn over n minus k. Now here, these are xy values, or I can call them as n comma gn, or you can call that as k comma gk, or these are x comma y values. X relates to n, y relates to the value at n. X relates to k, y relates to the value at k. Now what I can do, I first need to find out
Party. And then
these,
you wanna
meaning
come up
using
with-
these two, I can find out my R value. So first term is given, the third term is given. Can I take N as 3, R as 1? So basically that's what I did in the previous problem too. So G3 equal to K as 1. Kth term is 1. So GK, what is the kth term? G3 equal to G1 times R power n minus k is 3 minus 1, which is R squared. So R square equal to G3 by G1. What is G3 by G1? G3 is 10 by 4. Any questions still here? 5 by 2. R will be equal to square root of 5 by 2. Any questions still here, guys? Any questions still here?
No.
Abira, okay. Now I go back and substitute this. How to substitute? I have two x comma y values basically, right? I have the R value. So I start with, if I take, see, if I take this to do my final equation, I use 1 comma 4 point for my final equation. Gn, Gn equal to, so y will be equal to, you take this as y and this as x. Okay, so for the kth term, you substitute this or this. Now, first I'm going to take k comma gk as this one. If you take this, your answer will be y will be equal to 4 times r power. What is r? square root of 5 by 2 power n minus k. N minus k is what? 1. Suppose you take k comma gk as 3 comma 10, your answer will be y will be equal to y will be equal to this one. So here, what I'll take it as 10 square root of 5 by 2 power n minus 3. Any questions, guys?
Thanks. I was thinking. when we
Any
get back,
questions,
maybe-
Amma?
No.
I'll put n as x, Amma, because my final equation should always be in the format x and y, right? So avoid the n values.
If you want,
Can I give
could
you
take
one
over just
problem?
for
Would
10
you
minutes.
mind doing one of this? Let's see.
Next one. So she just enrolled.
A similar
So if
question,
you just wanna
not
see
much
what
of a
you think
difference,
about
but let's see whether you're able to do. How about this? Same, but I want you to write an exponential. Can we try that? Can we try that? Let me know if you can't. We will do it on the board.
Yeah.
Or you can do this one. Yeah, why don't you do this one? Why don't you do this one? This one looks nice. Like you to do this one. Pass us through these 2 points. Nitin, would you be able to do, or you want me to do once more? Let me know.
I can try doing it.
You want to go to, and how did the weather bonus get become so superior? I did.
Okay.
I think we spent more than.
So we actually do, we do 4 sessions, so, yeah, so this.
Let me know if you want me to do it on the board as well.
13th to the 3rd.
So find out our value
Yeah, so.
and then start substituting. Okay, the GKGN should disappear as GKGN will become Y. The N and N should be substituted with X. GN should be substituted with Y. And for GK and K, you can use the X and Y values that are given. Any 1 point is okay. You can take.
And this is column.
Yeah.
So actually, we do have to try to for all the orders.
I think that I did it online, that was the only way that we can find out.
Yeah, yep, so what I'm gonna do is I'm gonna go ahead and. It's complicated only because our system isn't great. So what I'm gonna do is just make a note now, to get column off of Q2 and 3.
Okay.
And,
Let me see.
we'll cancel the auto payments for
Okay.
November and January.
Okay.
Nitin, 19 by 3 or 19 by 9?
We signed up and ready to go for Q4. No.
Something feels wrong to me, Nitin, about the way. Nitin, okay. Shall I show you one difference, Nitin?
Yeah.
Here there are 3 R's in between. Did you see that?
Oh, because it's 2, 3. I mean 3, 4.
Exactly, 2 and 5, right?
Yeah.
So automatically they'll see there are 3 R's, meaning,
Is it the cube root?
yeah, exactly.
Oh, okay.
But is it 9 there? Correct.
Eh.
Correct. 19 by 9. Correct. Go ahead.
Okay.
With 3 and 9, I need to check, guys. 19 by 9. Okay, that is a problem with the. Oh, that is correct, Nidhi. You got a hang of it now? Yes, that is correct. Yeah, but replace the n with the x, right, Nitin? Your final answer should contain only y and x values. That's the trick there.
Okay.
Gn equal to gk a times n minus k, right? K and n is usually substituted with x. Gk, gn are the y values. What happens here? I don't know the ratio, right? So let me think about n is this, gn is 19. Gk is other value, kth term, right? R power of n minus k is what? N is what? 5, R is 2. Okay, so now 19 equal to 9 times R cube. R will be equal to cube root of 19 by 9. Now I plug this in back, but we need to be careful now. Why we need to be careful? So gn becomes y, gk becomes any term given, any xy coordinate, any y coordinate given. R, you know, and then n becomes x, k becomes the x coordinate given. So with this in place, I will rewrite my equation. Gn y will be equal to gk, any y coordinate given. I'll choose 2, 9. 2, 9 I'm going to use, okay? So gk is 9 times r cube root of 19 by 9 power n minus k value is 2. Suppose you use 5, 19 for the final equation, your answer will be y will be equal to 19 cube root of 19 by 9 x minus 5. Any questions, guys? Any questions?
No.
Can I move?
Yeah.
Abhiram, did you get it? Bhuvanesh, did you get it, Bhuvanesh?
Yeah.
Can we do one more problem? I was not that comfortable, very honestly. A couple of you got it, a couple of you didn't. That's okay. How about this? This is the last problem we'll do in this one. Please, guys, let's see. I would like to finish till regression today. Let me see. Sorry about yesterday, guys. Shall I show you? You want me to do it on the board or you can do it? Let me know, guys. I'm okay either way. At the end of it, you have to get it. That's all.
Yeah.
Are you able to do or do you want me to do? You have to let me know clearly, guys. Are you able to do or do you want me to do it on the board? Able to hear me?
Not properly.
If you want me to do it on the board, you have to let me know. Nitin, change the n to x, Nitin. Change the, see, your result answer should be as y and x, right? Your final answer should be in terms of y and x. Yeah, similarly, the left side should be y, Nitin. Abhiram and Bhuvanesh, did you get it?
I'm almost done.
Okay. That's right, Nidhi. Abhiram, did you get the answer? Abhiram. Abhiram,
Yes, no, well, the white paper can go.
did you
back.
get it? Oh, okay. Okay. Go ahead. I'll wait. Abhiram and Bhuvanesh, I'm going to wait. Nidhi and Nitin, please wait for a minute or two. I really want answers. If you don't get it, I'll do it on the board again. Sure, Bhuvanesh. Bhuvanesh, these are 2 points on the board. Okay. The 3 comma k comma gk, 8 comma 40 represents n comma gn. Nth term, kth term. This is nth term. This is the kth term. Okay, both are given, right? So I can find the R value now. Just plug in values. 40 will be equal to GK is 5. R we don't know. N minus K is 5, right? So R power of 5 is 40 by 5, which is 8.
Okay.
R power of 5 is 8. R is 5th root of 8. Bhuvanesh, did you get it till here?
Yeah.
After that, you're going to plug this in directly. But your final equation, so this I'm gn and n, I'm going to put it as y and x. Okay, y will be equal to gk r power r, we know 5th root of 8 power n is x minus 8. But what is gk? Let's consider this. This is k comma gk, right? In that case, k is 8, gk is what? 40. So 40 times, this is one answer. If you use the other value, right, y will be equal to 5, 5th root of 8 power x minus 3. This or this, they will accept. Can I move on?
Yeah.
Okay, now the main thing what we need to understand is, suppose a given function, see, the given function changes at a constant rate, it's a linear function. Suppose if a given function is, see, this is an additive relationship when you think about it. When you think about an exponential function, it is going to be, see, this is going to be a proportional relationship. Proportional, so exponential. Any questions? Can I move on?
Yes.
Okay, let's see this one. What else did I want to review? See, this was only a review of last week, I was saying. So let's see. How about we wrote equations? Okay, if you're given a linear function, you should be able to do that. It is easy. So let's see this one. What about this? Okay. Now we are going to discuss in depth on exponential functions. So let me go one by one. Coming to the general function, go ahead and write it down first. Exponential functions. I'm going to delete these because these are unnecessary and confusing. Okay, now when you think about the general form, f of x equal to a b power of x. What is the restriction? Restriction on a and b is, see, the initial value is here is a. This indicates the initial value, okay? But however, a is not equal to 0 and b is greater than 0. This is greater than 0. A is not equal to 0. Okay, now we are going to work. Okay, let's say what would happen if a equal to 1? What would happen if b equal to, see, b is greater than 0, right? Now tell me, one second. Mm, Okay, now what happens when b equal to 1? What would happen? What type of a function it will become? Let's say b equal to 1. What happens to the function? What will happen to the function when b equal to 1? Who can tell me, guys? When b becomes 1, what would happen? Let's plot the values. X, f of x, right? Okay. So when x equal to -5, what happens? X equal to -5, let's say x equal to -5, f of x, f of -5 will be equal to, a is not going to change, but b's value is 1. 1 power x, anything, 1 power anything is to -2. That will be equal to a 1 power of, this will be -5. Okay, this will be -2. Again, 1 power of -2 is 1. A. Now, f of 0 number of guys, you're all able to hear me or not?
Not properly.
Bhunesh? Bhunesh, you're able to hear me?
Yeah, but not properly. Keeps cutting out a little bit.
I see. Give me a minute, guys.
Welcome to Zoom. Enter your meeting ID followed by pound. It's not a
Hold on a minute, guys. I'll switch my audio. You're able to hear me now better? Abhiram, Nidhi, Bhunesh, Nitin, I would like to get answers.
Yeah.
Can I move on? Otherwise, let's all come on the video, guys. This is not going to work if this is the case. Meaning, I'm not able to hear. There is no point in, meaning, I don't know whether you're hearing. You're not answering. So I really want to know. So I can repeat this. B equal to 1, what happens to f of x values? When b becomes 1 in this equation, what happens to f of x values? Nidhi, are you able to hear me?
Yeah, I can.
Okay. But is it difficult? Meaning, are you not understanding, or you have to come out and tell guys this cannot
Your
keep
audio is a little
it?
bit muffled.
Oh, I see. Are you able to hear me, Nidhi, now?
Yeah, that's better.
Okay. So now, when b value becomes 1, what happens to this function? This is an exponential function which is of the format a b power of x. When b becomes 1, what happens to this function? What happens to this function, guys? What is this function? You're substituting b value as 1. So what will happen to this function? Nitin, you're able to hear me?
Yeah.
Okay, let's all come on the video, guys. This is bitches. Let's all come on the video. I really want responses. Let's all come on the video. Otherwise, I'll stop the class. There is no point, guys, go continuing this way. I really want responses. You all keep quiet.
Miss Priya, I can't hear you properly.
Yes, no, something I need, right? There is no point. Okay. Now what happens when b value becomes 1? What happens? F of x so it becomes a constant function. Let's a, this is a, y becomes a. Give me 1 minute, guys. Are you able to hear me now better? Hello?
Yeah, we can hear you
Yeah.
better.
Okay, so much better. Okay. So maybe my voice was not audible enough. Okay. So when here in an exponential function, when b value becomes 1, it becomes a constant function. Do you see it? Because if you substitute b equal to 1, your f of x value always becomes a. A can be a constant. So the exponential function becomes a constant function. Can I move on from here?
Yes.
Okay. See, you have to let me know, right? Whatever is happening at your end as well, I need to understand. Okay, let's move on. Okay. Now, let's think about when A is greater than 0, B is greater than 1. Let's think about the scenario when A is in the exponential function y equal to a b power of x. So the constraints were A should be A should not be equal to 0 and B should be greater than 0, right? So let's see. A is not equal to 0. So first, let me analyze I'm going to analyze 4 different situations, right? One, A is not equal to 0. B, let's say B is greater than 1, we'll analyze, okay? The second scenario we'll go ahead with is A is not equal to 0. B is between 0 and 1. 0 is less than B is less than 1. Can we analyze the two scenarios? What would happen now? In this case, if B is greater than 1, y will be equal to a b power. Let's say B is 2 power of x. So what happens when it goes on and on and on? Meaning, okay, when b value is greater than 1, it becomes 2 power of x. When x is 1, a 2 power of 1. When x is 2, 2 power of 2. When x is 3, 2 power of 3. So do you see the function keeps on getting multiplied by 2. So how would the function be? Let's say a is equal to 1. A is equal to 1. So let's say if it was still here. A is equal to the x equal to 0. Let's say x equal to 0. If x is equal to 0, 2 power of 0, right? 2 power of 0 is 1. It will be at a. So this point is 0 comma a. After that, it keeps on going up. You see, it keeps on getting multiplied by 2, multiplied by 2. So the graph becomes this. Whereas when a is not equal to 0, b is between 0 and 1. How will the function be? How will the function be in this scenario where a is not equal to 0? See, b greater than 1 means it keeps on. As an example, I considered b is equal to 2. So it kept on increasing. So I can call this function as an exponential growth. How about this? What happens when b value, here more than saying a not equal to 0, I can say a is greater than 0. Okay, here as well, a greater than 0. So what happens if b is between? I will consider an example again. Okay, so here y will be equal to a is greater than 0, right? It's a positive number, okay, any number. Now after that, the equation becomes b power of x, right? B is between 0 and 1 means it has to be a fraction, you see. So power of x. So now x equal to, let's say, -1, x equal to 0, x equal to 1, x equal to 2. If x equal to -1, what happens? A times 2. When x equal to 0, anything power 0 is 1. It becomes a. When x equal to 1, what happens? Half a. When x equal to 2, 1 by 4a. So what is happening to the value of y? What happens to the value of y if b is a fraction between 0 and 1? Guys, what happens, guys? Abhiram, can you say what happens when b value is a fraction? Abhiram, Abhiram? Nidhi, can you say?
Exponential decay.
Oh, okay, Abhiram, I get it. Your mic, okay. Exponential decay. Okay, so with the function gradually decreases from the value of C, 2 times a, half a, 1 by 4a. This is going to be an exponential decay. Now, let's consider these functions. When a is not equal to 0 is the original constraint. So when a is less than 0, b is greater than 1. What happens? What type of a function would it be? A is less than 0 means I will have y equal to negative magnitude of a, and then b is greater than 1. I'll consider it as 2 power of x. So what happens here? It goes on decreasing negatively. Do you see it? So here it would be -2 when x equal to 0. 2 power of 0 is 1. So it would be 1 minus 1a. Then x equal to 1, what happens? Y will be equal to -a 2 power of 1. So it keeps on increasing negatively. Do you see 1a becomes 2a, and after that it becomes 4a. So it gets on getting multiplied by 2, multiplied by 2. So what happens here? Let's say it keeps on going negatively. So here at 0, what happens? When x equal to 0, it is a negative a. So 0 comma negative a is a point in the graph, and my graph would be keeping on increasing negatively. The last scenario is a is less than 0, B is between 0 and 1. What type of a graph would it be, Nitin, in this case?
Between 0 and 1, as she said.
Yeah, yeah.
Would it be decay as well? Or is
Would
it
it, yeah, it would be decay, reflected decay, right? Because B is less than 1. So basically, it would be a reflected graph, right? Meaning, let's say y will be equal to minus a. It is between, let's say half power of x. So now x equal to minus 2, let's say. If I put x equal to minus 2, then it would be minus 4a. To start with, it will be a high negative value. To start with, in the sense at minus 2, it will be a high negative value. When x equal to minus 1, automatically what happens? It will be a minus 2a. See, the negativity decreases. So when x equal to minus 1, it will be a minus 2. It keeps on decreasing. The negative value keeps on decreasing. X equal to 0, it will be a minus a. X equal to minus 1, I'm sorry, x equal to plus 1, what happens? If it is a plus 1, then it becomes minus half a. When it is 2, right, it will be, when x becomes 2, right, so what happens? Half power 2, that is 1 by 4, so minus 1 by 4a. So see, the negative minus 4a became minus 2a, became minus a, became minus half a, became minus 1 by 4a. So basically, the graph will represent an exponential decay, but is reflected on the x-axis. Similarly, this side, right, when a is less than 0, b greater than 1, it is an exponential growth curve reflected on the x-axis. Any questions still here? Can we move on? Any questions, guys? Can I move on?
You can move on.
Okay. Now, let's say, how about this? Okay, how about this? Would I be able to get you to write this into an exponential function equation? Would I be able to let you write this as an exponential function equation? Let's see. Okay, before I move there to problems on exponential functions, right? So how about for an exponential function, let's bring back those graphs. For an exponential function, it is always concave up or concave down. See, this is concave up. This is concave up. Do you see it? This is concave down. This is concave down. There is no changing between concave up and concave down, which means that there are no inflection points. Another thing is, when you look at it, right, how to define the end behavior of exponential graphs? When x tends to infinity, what happens? So I can say an exponential function a b power of x, when x tends to plus or minus infinity, limit. What would happen? What will be the end behavior in these graphs? It either goes to plus infinity, or it goes to minus infinity, or it tries to converge to 0. Am I with you all in this? Did you understand what I'm saying? Okay. So the end behavior can either go to negative infinity, positive infinity, or it can try to converge to 0. Now let's go ahead and do one problem, then we'll know where we are. Let's consider this exponential equation. I want both. Okay, hold on. How about this? Let's consider this exponential function. I'm going to erase this. Now tell me, is the function increasing or decreasing? This function, is it increasing or decreasing? See, it always gets multiplied by 2, but is it increasing or decreasing? How to evaluate that? Is it increasing or decreasing?
decreasing?
Decreasing, why?
It has a negative slope.
Exactly. It has a negative. It has a negative slope. Nice way of answering though. It is a decreasing function. Why it is a decreasing function? When you think about it, right? Change x values. Initially 2 power of 0, minus 6 2 power of 1, minus 6 2 power of 2. So what happens here? The negative number keeps on increasing. That means it was minus 6, then it became minus 12, then it became 2 power of 2, right? 6 4 6 4 24 minus 12. So negatively it's going on increasing. So basically it's a decreasing function. Is the function concave up or concave down? Is the function concave up or concave down? See guys, I can plot this, literally I can plot this. X equal to 0, then it's at a minus 6. X equal to 1, it is at a minus 12. Then x equal to 2, it's at a minus 24. So basically it is this, right? So can you tell me if it is concave up or concave down? Concave down, good job. Now, limit extending to infinite, minus infinity. What happens when we go to minus infinity? The function tries to converge to 0. Similarly, limit extending to infinity. What happens to the function? It goes to minus infinity. Any questions, guys, here? Next one, I'm going to give it to you to decide. How about this? How about this? Can I get the answer for this one? You're going to do this by yourself. Let me know. If you can't, then I'll do it on the board. Shall we do that? F, let me take it up. F of x equal to 5 times 0.9 power x. Is the function increasing or decreasing? Is the function concave up or concave down? And then when x tends to minus infinity, what happens to f of x? When x tends to plus infinity, what happens to f of x? Can we do that? Did you get it, guys? Okay, there are some problems. Okay, that's nice, guys. So basically it is basically it is decreasing concave up, decreasing concave up, decreasing concave up, decreasing concave up, and then minus infinity. Yeah, really, Nidhi, is it minus infinity? Abhiram, you got it right.
Yeah, sorry, that was a typo.
Oh, minus. Okay, correct. Minus infinity 0. Okay. Yeah, Abhiram, you corrected it, right, Abhiram? Yeah, Nitin Bunish, can I get yours?
I sent it already.
Oh, sorry, Bunish. Decreasing concave up. Okay, the third and the fourth are incorrect, I feel, Bhuvanesh. The third and the fourth seem incorrect. So here, the function, how is the function going to be? 5 times, it's a fraction. When you keep on multiplying something by a fraction, then there is no negative. There's no negative at all. So it's no reflections, okay? It's going to be like this exponential decay function. So basically, is this function decreasing or increasing? Decreasing. Concave up or concave down? Concave up. Till this you got it. Now, limit extending to minus infinity. When x goes to minus infinity, what happens? The y value goes to infinity, right? Bhuvanesh, are you
That's
with me,
what I
Bhuvanesh?
said. Isn't
Wait,
it
wait,
not
wait,
positive
wait.
infinity?
Correct, correct. Wait, Amma, wait, wait. You got it right. Infinity and zero. Oh, okay, okay. I'm sorry, I got confused with Abhiram's answers. Okay, yeah. First set of Abhiram's answers, I got confused. Okay. Yep, infinity zero. Okay, now let's go ahead and try to understand this one more thing with respect to this. Let's say g of x equal to f of x plus k. What type of a transformation is this? If this is going to be an exponential function, can I say that f of x is an exponential function? If it is an exponential function, then the relationship between x and y is proportional. Relationship between x and y. Is proportional. There is always a multiplication factor, right, when we move up or down. So here, let's say there is an exponential function like this. Plus k means it moves up by k units. If it is a minus k, it moves down by k units. Okay, now let me go back and give you some problems on this. See, this additive transformation of an exponential function is important. And do you all remember suppose let's say I have a power of minus n. How is it written? A power of minus n. How is it written? Let's find out this one. A power of minus n. What is it actually? How to change that negative exponent? Do you all know? How to remove that negative exponent? Guys, you remember? You remember or you don't remember? Just tell me, I can move on, right?
I don't remember.
1 divide by a power of n. You see, now 1 divide by a power of minus n is push it up to make it into a positive exponent. Okay, this is from algebra 1. So whenever you have a negative exponent, right, to make it into a positive exponent, push it down. Similarly, when the denominator has a negative exponent, push it up to make it into a positive exponent. And similarly, do you all remember what is a power of m times a power of n? How do you do it? Meaning, what do you do? Same base, different exponent. What do you do here? This becomes, you can unite the base, but then add the exponents. This is the product property of exponents that we learned. You know, a power of m by a power of n will be equal to a power of m minus n. This is the quotient property. Any questions? And one more thing, what is power property we learned? I'm just revising the property of exponents. Power property is a power of m, whole power of n is a power of m times n. So we discussed quotient property, product property, power property. Any other questions till now? Are we good with this? Okay. Now let's say, okay, I have a function. Let's consider the horizontal translation of an exponential function. Horizontal translation of an exponential function. Let's see what happens to the horizontal translation of an exponential function. Let's say we have let's say we have f of x equal to a b power of x is our original function. Now, if you translate it horizontally, meaning change your x coordinate, either you add k or subtract k. I'm going to make it as a equal to 1. For simplicity purposes, we'll have a equal to 1. Now what happens? B power of x plus k, meaning I'm discussing horizontal translation of an exponential function. Horizontal translation. Okay. Now, by property of exponents, I can write it down as b power of x times b power of k. Are you all with me? So here, when you think about it, if b is a number, b is going to be a number, right? If b is a number, let's say b's value is 2, okay? When I translated this horizontally by k units, right? You see what has happened here? 2 power of x times 2 power of k. So my original function was what? I took this as 1 for simplicity. 1 power of x was my, b was considered as 2. For simplicity purposes, we took a is equal to 1, b is equal to 2. So my original function was 2 power of x. Now, if I translated k units horizontally, let's say I added, I translated k units horizontally. In that case, what happens here? I was able to use the product property of exponents and express it as 2 power of x times 2 power of k. 2 power of k is going to be a big number. So now that becomes a big number times 2 power of x, which is my original function. So did you see that the horizontal translation by k units became, what is this? Became what happens here? What type of a meaning, see, here you're going to multiply a big number with the original function. What type of transformation is that? Vertical? See, horizontally, you moved the system by 4 units, the function by 4 units. That's the same as multiplying the function by a big number. What is multiplying the function by a big number equivalent to? Vertical? Dilation. So how does this work? Let me go ahead and give you an example, so might be you'll understand it better. Okay, see, what happens? Let's consider this original function. I assumed 2, right? Let's consider this original function 2 power of x. It's an exponential function, right? Exponential function, exponential growth function, because this factor is greater than 1. Now, when you look at it, right, I am going to add, meaning 3 units to the left. I want to shift it 3 units to the left. So this is a horizontal, I'll change it, okay? My original function was 2 power of x. Now I changed it to, this is my transform function, horizontal, transformed, horizontal translation. Okay, so I'm going to put it to 2 power of x plus 3. That k value became 3 here. Now, if it is 2 power of x plus 3, how will the graph be? It will shift to the left or the right? It will shift to the left or the right? Guys, you have to let me know. I'm going to wait. Will it shift to the left or the right?
To the left.
To the left. Good job. So it'll go to the left basically. It'll shift to the left. Okay. That will be 3 units to the left. Now, by means of product property of exponents, I can write this like this, right? So I will name it as differently, h of x. Now, 2 power of 3 is what? A big number times 2 power of x. Now, here, h of x will be equal to 8 times 2 power of x, right? What is it then? This big number is multiplied by the original function. So what happens? 8 times vertical dilation meaning you are multiplying it by 8. Vertical stretch by a factor of 8. Do you see it? Here, if it is a vertical stretch by a factor of 8, automatically what happens? Again, the third here, this one, right? This one becomes the same. You see? So basically, h of x and g of x are the same functions. H of x and g of x are equivalent functions. The parent function was f of x. So A transformation, horizontal translation is the same as vertical dilation. Any questions here?
No.
Let's see this. With this, we'll conclude, Amma. Let's do 1 or 2 problems. We'll conclude there. Okay, how about this? How about this? Suppose if I am given a function g of x equal to 3 of x by 23 power x by 27. I'm given a function g of x equal to 3 power of x by 27. G of x equal to 3 power x by 27. Do you see now? What I want you to do with this function is, my parent function was 3 power x. Can you tell me what is the transformation that has happened here? What is the transformation that has happened here? Given this function, my original function f of x was 3 power x. G of x is the transformed function. Can you explain what transformation happened here? From f of x to g of x, what is the transformation? Guys, you want to go ahead or you want me to do it on the board?
I can try first.
Sure. So basically, what is 27? G of x equal to 3 power of x divided by 3 power of 3. By quotient property of exponent, this becomes x minus 3. So what is this transformation in here? Since there was a minus 3 in here, did it move to the right or left?
Right.
It moved right by 3 units. Or you can even say it was vertically compressed by a factor of 1 by 27. Okay, it moved to the right by 3 units. How about, I'll finish with this, guys. Okay, how about, let's consider, okay, let me finish with this transformation alone. Okay, how about we'll consider the same function, 2 power x. Okay, now let's consider the same function. I'm going to show you a horizontal dilation. Let's consider the same function f of x 2 power x. If it is a horizontal dilation, let's say I multiply the x value by 3. F of g of x. This is my transform function this time. Transformed. But I am going to talk about horizontal dilation. Horizontal dilation. So I multiply a number with x. That would become 2 power of, let's say, 3x. Now I can split this as 2 power of 3 times 2 power of x, right? So I can 2 power of 3 power x, right? Now what happens? 2 power of 3 power x, because 3 is multiplied by x, right? So I use the power property to split it like that. Now in this case, 2 power of 3 is 8. It becomes 8 power x. So a horizontal dilation of an exponential function results in the change of base of the exponential function. Any questions? Using the power property, you can change the base of the exponential function. So basically, a horizontal dilation in an exponential function is the same as changing the base of the exponential function. I'll show you the graphs in here. With this, we'll conclude. So here, do you see the original function was 2 power of x, the horizontally dilated function. What was the dilation in there? It was a horizontal compression by 1 by 3. That resulted, see, the blue graph in second and third, right? The here, the red graph here is the same as in here. So even if you change the base or horizontally dilate it, they both are one and the same. A horizontal dilation can be equivalent to the change of base in an exponential function. Can we stop here, guys? problems for the homework will only be based on exponential function, vertical dilation, horizontal dilation of exponential function. That's it. Any questions for me till here?
No.
Okay, okay. Can I ask you this? This one question and let you go. How about this? Suppose I have, what is the transformation in here? Meaning my transform function is this. My original function was f of x was 3 power x. It changed its base, right? So what is the actual transformation in here? See, when you look at it, it changed its base. But I can express this transformed function as 3 power 2 power x. Right? Or I can write it out as 3 power 2x. So what was the transformation that this function f of x underwent? Nidhi, would you be able to say?
It's a horizontal dilation by 2.
Horizontal horizontal means you have to invert it, right? You have to find the
Oh,
reciprocal.
yeah, 1/2.
Horizontal compression by 1/2. Horizontal means you'll have to reciprocal the number that's coming, and that is the factor. This factor is less than 1, so it's a compression. Suppose if you would have resulted with 3 power of half x, then you reciprocal it. This is a vertical stretch by 2. I'm sorry, horizontal stretch by 2. Because it is applied to x, it is always horizontal. If it is applied to y, then it is vertical. So here it is a horizontal stretch by 2. For horizontal alone, you will find the reciprocal. For vertical, you will take it as is. Suppose if you're given this is a vertical stretch by 4. This is a vertical compression by 4. You won't find the reciprocal here. Okay, but for horizontally, if it is applied, the dilation is applied horizontally, you will find the reciprocal, and hence this becomes horizontal compression. Suppose this reciprocal, this becomes horizontal stretch by 2. Can I stop here, guys? So these are the transformations on the exponential functions. Homework will be just based on this. Any questions? Can I stop here, please? Thank you, guys, for rescheduling it to today. We'll see you next Saturday. If you have questions, stay and ask.
Thank you. Bye.
Bye, ma.